Hi friends, this is Sunil Kashyap back once again for discussing the final part of temporals table. So the that is bitemporal table. Okay, so in part one, I have discussed about system period temporal tables. So those who have not seen the part one video, so can get idea what system period temporal tables do. So in system period temporal table, we do use two tables, one base table and another table as a history table. So whatever rows or data is updated or get deleted in base table, that is moved into that history table. So this is the work that system period table does for us, and in with the help of this we can query our data in past. So we can query our past data. And in part 2 I have discussed about the application period temporal tables. So where applications supply date or timestamps to describe the business validity of data, we can use application period temporal tables. So here we do use only one table, there is no history table. So we manage some portion of time, that is our business time with respect to application. That portion of time is managed. Okay, so in this part I am going to discuss the bitemporal tables. So these are the tables which has both type of all the capability of both system period temporal tables as well as application period temporal tables. So in bitemporal we are going to have two tables, one as a base table, another table will be used as a history table for recording the updated or deleted data, and we will play on application periods. Okay, so let's see the structure of the bitemporal table. So black ones like ID, VIN, annual mileage, rental car, average amount. These are the normal columns for the table, and even bus start, that is business start, and business end date, blue. Both of these columns are as well as both of these columns are application columns, but these columns will be used as a ATT, application period, or for managing period. So if you see the period business time, the second last line, blue business period time, here we are using bus start and bus end, these column, and the green one, system start, system end, transaction start. These three columns are going to give us the effect of STT, system temporary tables. So we are going to have the system time get will be recorded in these columns. And the last line, we are having a we are going to create a primary key on ID and business time. Okay, so we will be creating this table in our testing lab, and we'll do some insert and update delete. Okay, so this bitemporal, with the help of bitemporal we will be able to query like time travel query. We will be able to run such queries. So the collection of temporal feature in DB2 is also known as time travel query. uh, a date range can be assigned to each row of data to indicate when a row is deemed valid by your application or business. The table enabled to track such business validity are called application period temporal tables, and their business times are period can be in past, present, or future. So with the help of Bitemporal, we will be able to query our data in past, present, and future. So even there are few special register that IBM has introduced for querying in future. So by changing the business time or temporal business time and temporal system time, we will be able to query our data for the future time. So without changing any code, the time in our code, we will be able to query for the future reports or data. So in term of performance, according to the white papers of IBM, that is claiming that DB2 based approach for such application, the coding requirement is reduced by 90%. Okay, so that is a big saving, I believe. So 90% coding is saved, and even I believe the complexity of the coding is also decreased. So and IBM says that implementing just the core business time logic in SQL stored procedure or in Java required 16 and 45 times as many line of code. So that's a big saving. So that will give our application a big boost, I believe. So even IBM tester took furthermore IBM claimed that some tester took less than 1 hour to develop and test the required SQL statement. By contrast, coding and testing one of the homegrown approaches took 4 to 5 weeks. It's a big time. Beyond the uh, development cost, the length and complexity of the code also significantly affect the application maintenance cost. So I believe in future it will be greatly used for application wherever we need to manage periods, or we need to query the past data whatever updated or deleted. So any application which is going to have some audit, so that can use system period temporal tables. Other time based application which need to perform, they will be benefited with the ATT. And of course we can use the bitemporal for having all the good features of STT and ATT. So I will be explaining this query for finding the period gaps in at our testing, and I will be back again here after some time after testing. Okay. Okay, let me enter the password. Okay, so we are connected to test 105 sorry database, and we are using again the same version 10.5 fixspec 3a. So like the part 1 and part 2, I have files ready for table creation and insert. So let me quickly create the table that I have shown you earlier in slide. So I have the DDL in this file, the same DDL that I have discussed. So I'm creating this table. So table is ready. So let's see how many tables we have. Okay, so we have created this table, policy underscore uh, bitemporal bit. Okay, so this is the empty table, so we don't have any record. And let's see the syscat period first before creating the history table for this. So let me run the monitor, temporal monitor. So it is telling us that policy underscore bit is S, and even policy bit is A. So it is having both type of uh, P, period types, the effect STT and ATT. So but in this column we haven't defined any history table, that's why it is null. So let me create a history table for this. So create history table creation is easy. So we'll be creating it with the like statement. Policy underscore bit underscore hist like policy. So the table is created. So let me attach this history table to base table DB2. So this is a versioning command which is successful. So now I'll see the syscat.periods. So here now this policy bit hist is mapped with this base table policy bit. So now let me query this table, select policy underscore bit and history as well. So both the tables are empty, base table and history tables are empty. So let me insert some data. One insert is ready. So I have just inserted a one row. Let's see what it is. So here we are having this one policy ID 1111, and the annual coverage amount is 10,000. Car rental is allowed. Coverage amount is 0.5 million, and the policy start date is 1/1/12, 1st January 2012, and it is valid up to the maximum date that DB2 support. So here it is saying that this policy is entered into system at this particular time, and it is valid for maximum time that DB2 support. Okay, so for testing So let me query our history table once again. So with insert there shouldn't be any data, so it's blank. So now we need to update or delete some portion or uh, any another column, so that will generate or move the row from base table to history table. So I have one update ready, so let me explain you what is that. So according to this update, we are going to update the base table, and for just portion of time, this portion means 1st June 2012 to 1st January 2013. So for this portion of time I am going to change the coverage amount to uh, 0.25 million, and I am stopping car rental. So car rental will be N. So let me update this, so it will split this time period. So let's see. Okay, so it ran. Let me select the data. Okay, so earlier there was only one row that is got splitted into three. Okay, so let's see. So this portion we are going to have a one row. So let's see where is that. So the first one is the new row. This is a new row, and this one is got splitted, and this is got splitted with the uh, January 1st January 2012 to 6th June 1st June 2012, and here onward we are having this new portion of uh, time for this. So we have ran the update, so whatever the original row was present or got updated here, we should be able to see that one in our history table. So let me show you that history table. So in history table we are having that row now. So this was the original row that got updated and splitted in base table. Okay, so this is the basic testing of bitemporal. So what other problems we could have with the bitemporal, that is something as we have created a primary key on ID and just a minute, primary key on ID and this business start and business end. So might be we may have some gaps by after inserting new rows. So we let me insert one row again, so should that may have some gaps, then we will test the our data. So I have one more insert, so let me run that. Okay, so one more row is inserted into base table. So let's query the base table once again. So one more row is present now. So in this we have inserted this a period to 2010 uh, June 1st June 2010 to 1st January 2011. So this should be here in this table. So last row, this is got inserted here. So as we can see, we are missing some periods. So if you see the policy 1111, this is the minimum start date is this, and this is ending on this 1st January 2011, and again this is starting on 1st June 2012. So there is a gap. So I believe it is starting on 1st January 2012, but still there is a gap. So how do we detect gap? I showed you the query for finding gap. So let me run that here, the same query. So this query finds the gap for us. So it is saying that we are missing 1 year in this table. So why I am explaining this? Because if we are creating tables with referential integrity, and our primary key is defined same as here, ID and business start and are the part of that primary key. So whenever we are inserting some data in child table, that may get fail, and sometime even we may get error when we are inserting some data in parent table. So we may face different issues with the referential integrity. So referential integrity with temporal tables a little bit work differently, because with the normal referential integrity, only ID is, or some other column, integer column, are the part of primary key or foreign key. But here time is involved, and we may split or our time, or we may break according to our application requirement, that gap that may produce some different kind of effect with in our data. So that's why we need to find out all the gaps for bitemporal type or ATT type of tables. So okay, so let me show you the referential integrity for temporals. So data modeling and referential integrity for temporals. Okay, so this is something that I have already explained you, that we may face the error whenever we are inserting rows in a child table. There could be a problem with the update rows in the child table at the time of update. At the time of deletion of rows from the parent table, we may have the some effects, and update row of parent in parent table can also cause the issue. So So for managing all such kind of issues, we can create some triggers. So if the triggers are predefined, and in the definition of triggers we are managing referential integrity with gaps, so that will be good for our data, even for application. Okay, so here is a trigger uh, uh, for managing referential integrity, so temporal RI. So suppose there is no gap in period, then this simple trigger can insert new rows or new data in our child tables. Okay, so that will be taking care of all the aspects of gaps and referential integrity between parent and child table. So we may have gaps, so it's better to write a trigger which can detect the gap and then do insert or update. So this was the trigger for insert, and we can create trigger for update. So just we need to say before update, and the rest of the things will be same like as we are going to write in insert trigger. So this is the insert trigger. Here we are writing the update trigger. Okay, so now this is something I was discussing, that we may have the gaps in our table, so it's better to find out the gaps whenever we are inserting or updating data. So this is a trigger with the referential integrity for managing the referential integrity with gap. Okay, so the triggers are can be used whenever we are having a very less amount of data. So whenever we are inserting or update few rows, so because triggers are triggered at every row level, so whenever there is a update or delete, the triggers will be triggered as many times based on the number of rows affected. And so suppose we need to update or delete a very bulk amount of data, so that can be done with the help of stored procedure. So in case of stored procedure, that will not be, the triggers will not be triggered at every row. So we can, with the help of stored procedure, we can copy, delete the rows that violate the temporal referential integrity. So here we are having the same that I have discussed. So that's all about temporal tables. I may post one more video for best practices and for administration of temporal tables in DPF environment. So but I am finishing this video now. So today I have discussed the bitemporal tables. Thank you.